The objective of this lesson is to express a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100. In previous lessons, students explored fractions with a denominator of 100. In this lesson, we will explore the relationship between fractions with a denominator of 10 and those with a denominator of 100. Let's begin by labeling this flat place value block as the whole. In previous lessons, this block represented 100 units. But for this lesson, it represents one whole. We can partition the whole block into tenths by creating 10 rods. If we were to look at only 3 rods, we would be focusing on 3/10 of the whole. Notice here we use blue to identify the 3/10 blocks. Next, let's imagine what an equivalent fraction to 3/10 would be on our hundredths block. We have shaded in blue the leftmost 3 columns of tenths. On our hundredths block, each column has been further partitioned into 10 smaller pieces. We can shade an equivalent 3 columns on the hundredths grid in red to differentiate between hundredths and tenths. We have shaded 30 hundredths. 3/10 is equivalent to 30 hundredths. When we partitioned the whole into 10 pieces, we are creating tenths of a tenth, which is also known as a hundredth. 10 hundredths are equivalent to 1/10. 10 tenths are equivalent to 1 whole. Notice how 10 of one value is equal to 1 of the next larger place value. Remember, 10 times 1 is 10. 10 times 10 is 100. 10 times 100 is 1,000. This will help students as they work with place value of tenths and hundredths. We can prove 10 hundredths are equivalent to 1/10 by multiplying by 10. 10 groups of 1/100th can be represented as unit fractions in this way. Notice how 10 hundredths are equivalent to 1/10. 10 100th-sized pieces will make one piece of the next largest place value, tenths. We can also prove 10 tenths are equivalent to 1 whole in a similar way. 10 pieces that are 1/10 in size will make one piece of the next largest place value, 1 whole. When discussing place value fractions, it is important to correctly name them. For example, these two fractions are equivalent. On the left, we would describe the fraction as 2/10. On the right, as 20 hundredths. Both would be represented by shading 2 columns on their respective tenths grid or hundredths grid. Similarly with mixed numbers, using appropriate naming is critical. Here we have 1 6/10 or 16/10 on the left. On the right we have 1 60 hundredths or 160 hundredths. These values are equivalent even though they are stated in different terms. We can create a multiplication equation to support these equivalent fractions. For example, 2/10 multiplied by 10 in the denominator and 10 in the numerator would become 20 hundredths. We used 10 as the multiplication factor because we are decomposing each tenth into 10 hundredths. The objective for this lesson was to express a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100. We met this objective by examining the place value relationship between tenths and hundredths. Using this, we examined equivalent tenths and hundredths fractions using place value models.